Hey, everyone, let's do question 5, functions for grade 12. Question 5, 5.1. The sketch below shows the graphs of f of x is equals to x squared minus 2x minus 3 and g of x is equals to x minus 3. Then we're given some pointers there. A and B are the x-intercepts of f. The graphs of f and g intersects at point C and B. C is the y-intercept of G and F. As you can see there, it's a point that is on the y-axis. D is the turning point of F. It is important to read these questions carefully before you attempt to answer them. So 5.1 says determine the coordinates of C, the y-intercept of both G and F. It's only one mark. The y-intercept there is, you set x equals to 0. You can use any of the graphs. I will use g of x. X is equals to 0 there. Then y will be equals to 0 minus 3. Y will be equals to negative 3. So the coordinates will be 0, semicolon, negative 3. 5.1.2. Calculate the length of AB. The length of AB. To get the length of AB, it's on the x-axis, or the coordinates of A and B are the x-intercepts of the graph of f of x. So let's set f of x equals to 0. F of x is equals to this, x squared minus 2x minus 3. Set that equal to 0. 0 equals to x squared minus 2x minus 3. We can factorize this. Use 3 and 1. We are looking for the values that if we add them, they give us negative 2, and if we multiply them, they give us negative 3. So it's going to be negative 3 plus 1. If you expand this, we're going to get back to that one. If you multiply these values, they're going to give you negative 3. If you add them, you're going to get negative 2. So x will be equals to 3, or x will be equals to negative 1. So the length of AB will be equals to, it's always the bigger minus the small. So 3 minus 1, you get your 4 units. To get the length of any line, you say the bigger value minus the smaller value, minus. So whether the smaller value has a negative sign or not does affect your answer, so you must take care of that as well. We go to 5.1.3. Determine the coordinates of D. D is the turning point. There are many ways to do this. I think I'm gonna go for I will try them both. First of all, the x coordinate of the turning point, you can get it by taking the average between the x-intercepts of the graph. So you're gonna get that x1 plus x2 all over 2. So this will be equals to my x1, I will choose A is negative 1, plus B will be 3 over 2. I get 2 over 2, which is 1. And then for the y-intercept, for the y-intercept, I substitute on the graph of f. So f of 1 will be equals to 1 squared minus 2 times 1 minus 3, and this gives me 1 minus 5, which is negative 4. So the coordinates there are 1 comma negative 4. The other way is to use the x coordinate of the turning point is x is equals to minus b over 2a. I think we know this from grade 11, which implies what is my minus b? Minus 2 over 2 times 1, which gives me 1. And then you substitute this one back into the function and you get the same coordinates. Another way is to use calculus. You know, at the turning point, f prime of x is equals to 0 at the turning point. Let's do f prime of x is equals to 2x minus 2. We set that equal to 0. 2x minus 2 equals to 0. You get 2x is equals to 2. And then you divide by 2 both sides, you get x is equals to 1. The same thing using calculus. So this is basically the same. And then you substitute this back into the function to get the coordinate. So let's move on to 1.4. 5.1.4. Calculate the average gradient of f between C and D. Between C and D. Now we have the coordinates of C. C is 0, negative 3, and D is 1, negative 4. To get the average gradient, M we know is equals to y2 minus y1 over x2 minus x1. This will give us, I will choose this to be my y. I will choose this to be my y2, or my y2 is this one. I'll take negative 4 minus negative 3 over 1 minus 0. Because I took this to be my point 2. So I took negative 4 minus 3, which is negative 1 over 1. And then this implies that m there is equals to negative 1. (5.1.5) Calculate the size of OCB. Calculate the size of angle OCB. OCB. Okay, we have a right angle triangle there. Let me do that again. We have a right triangle here, and then we're supposed to calculate the size of OCB. The angle, this is my O, this is my C, and this is my B. We are looking for this angle. We have a 90 there, and you can get the length of this line, and we can also get the length of this line or the length of this line. It's easier.